All right, part two. If you would color in or stripe one standard deviation from the mean on either side, so you're going to that point of curvature on the right and that point of curvature on the left. If you would draw that and stripe or color it in, that the mathematicians came along and told us that is 68% of the area under the curve. So 68%, we have to memorize that. So if I was only interested in one side of that striped area, this side would be 34, and this would also be 34. So that sometimes it'll be helpful in knowing how to do that with problems. So 68 is divided into 34 and 34. Then the mathematicians went out and they went 2 standard deviations from the mean. So I'm going to get rid of what I've written underneath there.
I did it like 3 times.
Yeah, it's just so
And
small.
it's still not good enough.
Alright, so now I'm going out 2 standard deviations from the mean, and the mathematicians came along and told us that that is 95% of the area under the curve. You have to memorize that. And lastly, 3 standard deviations from the mean on either side comes out to 99.7%. So we call that the 68, 95, 99.7 rule. It's true for any normal curve, so it's also true for this one, or any normal curve. 68, 95, 99.7. Any statistician anywhere, you could walk up to him and say 68, 95, 99.7. He'd know exactly what you were talking about.
Get really excited.
He probably would. Say, it's so cool. All right, let's finish today by putting in the percentages that you would need to finish your problems, which we won't get to tonight, sorry. But we'll do
It's
it in
okay.
class tomorrow.
What a shame.
Yay!
What would this section alone be if this is 68 and this whole thing is 95? I want just this part. So we would have to subtract 68 from 95 and divide it by 2 to get just this part. What is that number? Someone tippy tap it out for us. 68 from 95 divided by 2. Got it, Julia?
Is it 13.5?
I'm hoping you're right. If you did what I said.
Can someone
I don't
check
know
me?
these by heart.
I was supposed to subtract 68 from 95 and
divide
then...
by 2.
Okay, yeah, I
Right.
did that.
So that means this little purple stripe is 13.5% and this is 13.5%. And now I need these 2 out here, the little parts, which I've over exaggerated in size, but it'll allow us to see them. We have to figure that out, so that would be 99.7 minus 95 divided by 2. So we got that, Julia?
2.35?
All right, sounds reasonable. So that little part there is 2.35, and this little part here is 2.35. That's any normal curve, not just the particular one I drew there. So if I was going to draw a normal curve, and I knew, remember I told you it was completely defined by the mean and standard deviation. Say the mean is given as 6.854 and 6.84, and the standard deviation is 1.55. Your book will say draw that normal curve and label it. So you need to know what they're asking. That's always the hard part, right? So you would draw a bell-shaped curve. You would put in the mean as 6.85. Julie, I need your calculator again.
Okay.
So find the point of curvature on each side. Put in, that's the one standard deviation from the mean. So Julia, I need you to start at the mean, which in this account, this is 6.84.
Oh,
I got 1 minute. Add 1.55, and what do you get?
just add this together.
Yep.
8.39.
All right. So do you see why I got that? This was 1 standard deviation from the mean. Here's the mean. So 1.55. The next one, 2 standard deviations from the mean. Julia, add to this number 1.55.
$9.94.
And one more.
$11.49.
11.49. All right, now let's go backwards. So from 6.84, subtract 1.55. We're going this way.
5.29.
And again,
3.74.
and again.
2.19.
2.19?
Mhm.
All right, I think we do have enough to do some problems. What you will do is, on 2.2a, you'll have to do that same thing. So do number 41, and then try to get the percentages. So I'm just going to have you do 41 and 43. How many are on the days? Let's do the first 3. Then we'll do the second 3 in class. All right, give it the old high school try. All right, that's it. We're done.
Thank you. Bye, Ollie.
Bye.